हेलो। 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 ओके। इधर। हेलो। हेलो। हेलो।
Which file I don't know. So many times happened. Hello, hello. Hello, hello.
Hugo. To me up top. And
This one, sir.
what is this?
January 11,000. Opens.
From there directly.
Sharing.
Hmm?
Okay, sir. We'll share it. I am telling to you. Share. We will share
Okay, get back to the Hare Krishna. Is the PDF.
Which one? Okay.
Okay, so Suprabhatam, Shubhodayam, good morning, and Changa Shavera. So, how are you doing in IAB? Great. Today is a really momentous day in the journey of NIAB. 6 years ago, we entered this new campus. This is the day when this new campus started its new journey. And this is the day to remember all the efforts every member of this wonderful community put together to take the first step in this campus. So on behalf of our director, Madam Dr. Taru Sharma, our event management committee, I welcome you all to this commemoration and remembering of this momentous day. I'm really happy to see quite a big crowd today in this beautiful Sunday morning. For today's program, we'll be hearing a lot about how this institution and this institution day came off from our previous director, sir, Dr. Subir Majumdar, as well as our current director, Dr. Taru Sharma. So now, without more introduction to this event, I will invite our Honorable Director, Taru Sharma, to share her thoughts.
Thank you, Bhakaditya. Well, good morning to one and all. Greetings for this Institute Day. At the outset, I, on my own behalf and on behalf of all of us and the fraternity, sincerely thank you, Dr. Sudhi, for having accepted it and being with us. And surely, as was said 6 years back, so there are some memories which always remain, and we remember them very vividly and we cherish it all through. And undoubtedly, this is one such day. 6 years ago, I'm sure more than 40% of the people who are here, led by you, have witnessed that day when people entered this campus, this beautiful campus, and made it to what it is. And the incredible people out here, students, fellows, employees, scientists, and everybody, have been moving through, walking through with all untiring efforts. And on this day, from 2018 to this day, 11th August 2024, Dr. Sudhi, without boasting, with all humility, I must put it on record, especially when you are here, that people have really been doing it as if this is their heart, soul, and their cheer, whoever they may be, right from, I mean, I won't say top to bottom, I say everybody in the circle. Because top and bottom is a very old school of working style. And I don't think that I'll say more because we would like to hear more from you. What I really was very pleased to see the title which you gave. You know, animal biotechnology, it's really a precious stone. I believe the preciousness of this very sector is much more realized by the people who are sitting in periphery, or they must be part of the inner circle of this. So with that, I once again greet one and all, and we look forward to hear from you. And once again, we really feel very happy that you could make it for the Institute Day lecture. Thank you very much. Are you going to invite? Thank you.
Okay, so I'll now invite my colleague, Dr. Yashpal, to introduce Dr. Shubhit Majumdar.
Very good morning to all. It's my honor and privilege to introduce today's distinguished guest speaker, Dr. Subir Majumdar. Although he scarcely need an introduction to this audience, being a former director of this very institute, his vast contribution to the field of science and his achievements deserve to be highlighted. Dr. Majumdar is a renowned scientist and academician holding prestigious titles such as Fellow of the National Academy of Sciences, the National Science Academy, and the Indian Academy of Sciences. His academic journey began with an MSc from Nagpur University, followed by a PhD at National Institute of Health and Family Welfare, New Delhi. He further refined his expertise with postdoctoral research at prominent institutes in the US, including the Southern Illinois University and the University of Pittsburgh. In his illustrious career, Dr. Majumdar has served in various pivotal roles, most notably as the former director and distinguished professor at NIIB Hyderabad, and currently as the Director General of Gujarat Biotechnology University. His research has significantly advanced the field of animal biotechnology, genomics, and reproductive biomedicine, with significant work on transgenic animals, livestock genomics, and therapeutic protein production. While his list of awards are extensive, to name just a few, Dr. Majumdar's excellence in research has been recognized with awards including the J.C. Bose Fellowship, the Tata Innovation Fellowship, and several prestigious Oration Awards. In addition, he has a long list of research articles published in prestigious Indian and international journals. His lab continues to push the boundaries of science, focusing on innovative biotechnological solutions, both for animal and human health. In today's lecture, Dr. Majumdar will delve into the topic of animal biotechnology, which he describes as precious stone in the ring of medical biotechnology. Please join me in welcoming Dr. Subir Asmi. Welcome, sir. Stand here and you can touch it. Okay.
No need to
ये
ये
best. But you can touch it.
whatever Ravi said we will do. अरे क्या है तू इधर कुछ हो रहा है इसका
अरे,
ऐसे पायदान नहीं है वो यहाँ खड़े रहने बेटा तेरा एक माइक घूमता है ना बस भाई ये बता कि वहाँ जा अगर वहाँ जाता है चल रहा है क्या चलता है गुड मॉर्निंग So, here I am grateful to Raghu Sharma and we have very soon Sunday for to come here on a Sunday. I think the reason we is very auspicious there for this institution. So we know and that moment must have been very nice and good. Ramesh, how are you? Really well. All the scientists who were involved in their two jobs. And so with this, I will go into my talk and He needs to be promoted. Good. So, these are my students who work with me, and either in lab or as a PhD student. And they are from National Institute of Immunology to National Institute of Biotechnology. And now I am in Gujarat Biotechnology. So, why animal models? Ample of animal patients are there. Ideally, we can do experiments with human patients. But what happens, patients, I gradually when I unfold, I tell you, human patients come one by one. In fact, patient talking 1 hour. And it will be interesting, so you will not be bored, I'm sure. So we can do the experiment, we cannot do experiments with the human. Then whatever patients come, sometimes the general we say n is equal to 6 चाहिए, n is equal to 4 चाहिए. Human patient तो कभी अकेला आता है. Let us say rare diseases, genetic diseases. A lot of other reasons which I will unfold. Associated with that. Only by keeping others constant. But normal blood pressure and normal कोई नहीं है आदमी. वो ग्लूकोज ज्यादा होता है तो उसका बीपी भी ज्यादा रहता है. आजकल फैट लिपिड प्रोफाइल भी बिगड़ जाता है. But if you want to control and study only changes in the glucose, you need to have selective possible to be done in the human. In addition, to test hypotheses about how disease develops, an adequate number of similar subjects must be used to statistically get a right result. So what journalists ask you, that n is equal to 6 must, that those 6 must be of the same standard and quality. It's difficult to find out that, but in animals it is so easy to find out. The data is repeatable, answer or whatever you find out is repeatable. So I will also in between go from time to time that this is where we started. I joined, I think, on right? And this is 15th August we were celebrating. I don't know whether you can recognize this place. What is this place? This is from where Santosh and Jagdish entered in the building, store site. And that was our first, my first 15th August, or maybe this campus is first 15th August. And this is where we started in a very small rented place where we used to enter into institution to go up. And surprisingly, I am extremely lucky. I came to I went to Gujarat for the first directorium. It's a wonderful auditorium. So God ने मुझे 19 में हमेशा बोलता है developed. And it was good that we had an auditorium there, and this is what a small bunch of people, small scientific workforce. And you have to keep thinking what it is. Can you imagine what it is? This is your library extended outside. That is the structure which was at that time. And this is the day when our Honorable Minister inaugurated in 2018 this beautiful building, and by that time it was a presentable building. This is how we used to celebrate 15 अगस्त के गाने बजाने होते थे इस गाय की तरफ. And now at least we started then doing it on the reception area. These are the transformations which are brought, and this is the particular place where you are sitting, and we have done and maybe continuing to do a lot of education. And this is the first batch of and maybe Pankaj and I think so. Yeah. So this is what is your institution, half built. This is the road. This was not a road, but this was being built. And later on, this is converted into this. This is the whole family of the NIAB, and we are proud to be together. अगर आप ध्यान से देखें तो आपको साइड के पेड़ नहीं दिखाई दे रहे हैं यहाँ, तो बाद में हुए थे, राइट? When you come to the topic, there are a lot of diseases. This is Guillain-Barré syndrome, and this is osteoarthritis. So these are several diseases of man where you have to really very difficult difficult to have a large number of such patients to provide of scientific service. Diabetes, we don't know them, but their potential to give you a disease. Study well, you will find the details. It gives mice which is a diabetic, but without being obese. It mimics insulin-dependent diabetic mellitus. So basically, this MDX mouse is X-linked muscular dystrophy due to mutation in the mice dystrophic gene. And it is also an example of a spontaneous part. And then they serve us as a model. To the models for human diseases have been made by mimicking same gene in mice that is responsible for human conditions. Several types of cancer, diabetes, hypertension, metabolic and hormonal disorders, diabetes, obesity, glaucoma, etc. have been really very useful for animals, are useful for them. Nonetheless, despite promising results with certain preclinical treatments in animal models, they are not necessarily going to give you a direct relation or directly translate to human. Some of them, you replicate all the symptoms. This statement is particularly true for neurodegenerative diseases, most of which involve cognitive deficit, like Huntington's disease. The cognition and the behavior and the response and reactions are not seen in mice so well as it can be seen in monkeys, for example. Non-human primates have become to up to non-human primates. So these are the things which are definitely going to be helpful if you keep it to monkey model. So this is a monkey model, and this is a story of whatever is in Bombay. What is that? Elephant attacks. Right. So monkey, see the behavior. He's the bottle in front of me. And monkey models for that, and monkey becomes that very guinea pigs. So guinea pigs and most people respond like human beings. So therefore, there are models of guinea pigs. Just 20 questions. There are 20 questions. And it will be used important for that reason. Another major advantage of natural disease models that is jump. There are reports that if somebody is having HIV, then you know the person very easily get TB infection. See, so this is a co-infection. See, if you do not have a disease, others may not occur. So this is a model where both diseases should be there. Otherwise, you now, let us say for that, I give you an example. Usually, model for respiratory viruses. Now, surrogate models can be used to understand the role of various aspects of immune responses, including innate, acquired immunity, as well as that these findings can be correlated with protection against infection. You cannot infect a human being after vaccination. Has been found to be more or less in the human. So as I see and look at your faces, and we see the slides depending on the interest and impression and view. So the advantage in animals were frequently used as model organisms in early 19th century for drug discovery. Vaccines for many diseases, smallpox, and that's rabies, typhoid, were discovered in animal experimentation. In early 90s, treatment for rickets, vitamin C, local anesthetic vaccine for tetanus, antibiotic vaccine, vaccine were discovered and it served the purpose of humanity. With the advent of 20th century, various modern developments were made with realized scientific era, mechanism and treatment of diseases like cancer, AIDS, influenza, and several other diseases recently. COVID-19 were discovered using animals. The contribution of animal life in experiments in millions of human lives all around the world. So let us say that how this is popularity. They found bacterial sepsis occurred in 200 of every 10,000, or sorry, 100,000 births. Nation, 60 of every 100,000 men aged 45 to 64 died from lobar pneumonia. There was no treatment. When sulfonamide drug became available, these figures fell rapidly. For example, death from 200 per 100 births reduced to 5, and the pneumonia reduced from 60 to 6. The story behind introduction of the sulfonamide drugs, how I'm going to tell, because some of you can challenge studies can also show you drug resistance, the drugs are working. There are a lot of models, but look at biolaboratories, and he insisted that the candidate compounds will be all candidate compounds he was studying will be screened in infected mice using so-called mouse protection test, rather than against bacteria grown in agar plates in presence of those compounds. Thomas perspicacity was fortunate. The compound controsil, for instance, proved to be extremely potent in mice, but it had no effect on bacteria in vitro. Why? The active antibacterial substance sulfanilamide was formed from controsil within the body. Scientists synthesized other more powerful sulfonamide drugs and give the successfully for the infection, and for this he got a Nobel Prize in 1939. So body drug physiologically into another drug, that is what is active. So that only a body can happen, and it cannot be done. That's are also to be told that this is not necessarily possible. So research and share the major share, and in addition to that, we know that we monkey and dog, and now a lot of transgenic animals are used for the statistics. An example, is it that if I take normal mice, normal people are not organism for, let us say, SARS-CoV-2. If it is a mice, it has got a receptor, a mouse ACE2 receptor hanging outside the lung epithelial cells. It does not recognize the virus. If we infect the mice with virus, it will not be suffering from symptoms of COVID-19. No. But what we did, that we have expressed the human gene for the receptor of human AC2 in mouse by making a transgenic mice. So this lung receptor started expressing, lung receptor started expressing this. Then this virus could really get tagged to this and internalized inside the cell. And now you have a wonderful model for all the SARS-CoV-2 vaccine development in the early stages. So you can manipulate the mice and can make it a humanized mice. And then you can study a human using the way it progresses in human. And then it is study, I not go to correctly giving vaccine, the mice survives and lung is not. If you do not give vaccine, the mice die with an effect in the lungs. So what is a transgenic mice? These are slides which you can see before some of you. So transgenic mice, human gene, let us say that is in violet color, can be taken and transplanted to the mice or rat, for example, is recorded, and it will be really taking place in the chromosome of the rodent, and it will express in a humanized, that means they will display gene related behavior or expression or phenotypic expression कि जो आदमी में है वही चीज आपको माइस में दिखाई देगा. So single gene knockouts cannot insert there, and one has to be really lucky that knockout a single gene model. The huge of any disease has to be more. So let us take an example, and this is the example of the PAX ortholog in various species. In human, it gives you this kind of mutant with an opaque eye. In mouse, it really gives you a decreased size of the lens and fused to cornea. And in zebrafish, it gives a pattern which is eye decrease in size and lens increase in size. And if you go to Drosophila, it is almost eye in case of human being, no opaqueness. In case of mouse, it should not be lens should not be fused to cornea. In case of the zebrafish, there should not be a decreased size. For example, but you have a model where you can see the reverse or not. Necessarily, it will not be exactly same phenotype. So remember that. And we can leave Pasteur and Robert Koch to study the causal relationship between infectious diseases and microorganisms. Certain diseases are caused by the microorganism. So animal experimentation in hypothetical, there are a lot of activists or what we call as anti-vivisectionists. Vivisectionist is a person really on animals. There are people who think that experiment should not be done. And in several respects, the experimental animals were carried out in the last decade of the 19th century to find the effective, reliable ways of treating and preventing diphtheria, determine the use of animals. So those people were finding don't use animal. But many common routine and animal tests in the quality control of the immunological arose from the diphtheria research. Conversely, diphtheria was one of the first diseases where experimental animal research laid the foundation of effectively reducing child mortality. And since it was an emotional random, any experiment could discover how to save the patient suffering from diphtheria, human beings all over the world started having emotional support to the field of scientific research. The first vaccine in animals, you know, in 1796, it was done by Edward Jenner, an English physician, who created a smallpox vaccine by injecting first from blood with cowpox into body of a young boy. And you must know, if not, go and read it. So, with the boy was protected because of that, Jenner decided to call the new procedure vaccination using Latin word cow, which is called as vacca, and cowpox, which is called as vaccine. So, a lot of studies are done now with vaccine virus and they design good constructs from that. In 1879, Pasteur developed the first laboratory vaccine for chicken cholera based on the observation that bacterial cultures weaken and become less virulent over time. So this was an accidental discovery. A fortunate accident that took place when Pasteur's assistant forgot to in culture and went to conservation. He came back. Instead of with the bacteria, he isolated, so he injected those bacteria, and what he found that the mice did not die, it survived. Ideally, it should die. But when you recharge it with a fresh bacteria, again mice survive. That means if you bacteria for several cycles or time period, it becomes weak, and the same bacteria which is infecting can become a live attenuated bacteria, and you can do the immunization. And that's how we first developed this first vaccine. Sorry, forget about it. I'll come to another important in animal biotechnology at today's date. So, how the lecture I will give you the examples of animal biotechnology, how that's a precious thing for medical biotechnology. And other half I will talk about the science. So here nowadays you can do surgical biopsy of the cancerous cells. You can cut into small pieces and culture them, and you can have a immunodeficient mice, which is further gamma dehydrated, and you can inject in that human HSCs, hematopoietic stem cells, and now you have a humanized mice. So the blood cells are that of human. Now from the human cultures of the tumor, you can make a xenograft, and you have got a patient-derived xenograft model with human immune systems, rather than just using nude mice with a cancer. And this is now used in several places. Then what you can do that you have for example, your liminal HER2 triple negative cancers, you can call them ABC and culture them separately. And then you can develop such patient-derived mouse with implants from A, B, and C, and then can trace different drugs, drug 1, 2, and 3, and can find out for which particular type of cancer which kind of drug is active. Now they have gone further, and what they have done induction of immunogenic antigen. This is very, very important. If your body is constantly fighting with the cancer, but if you take out the cell and put it in a nude mice or an immunodeficient mice, fighting the cancer. It doesn't try to bother cancer cells. Cancer cells, which are cancer cells, they are very annoying. And when you go to such mice where there is no resistance, it starts expressing the antigens in large amounts. Then isolate these cells from the mice with the cancer cells with large amounts of the receptors which are cancer cells and actually used for immunizing human beings. So now human beings, for example, 10 or 15 receptors per square centimeter of the body are seeing 10,000 receptors per square centimeter. If the antigen is high in amount, it is visible to the body. So what antibody for that? And wherever those cancerous cells are residing in human's body, it will go and attack and try to kill them. So this is a very, very new technology which people are using now. So basically, if you want to do such kind of cancer studies, you must have a system where you have to cross the bridge with so many things required before you go to clinical approach. And such mice, you can give a complementary drug which you are developing so that they can give you very safety efficacy of the system as well as the drug before you reach and go to human beings. And I had made experiment and they found that the drug VLPH1 is the best one and VLPH2 do bit good but not that good. And these are the diagrams of that. Don't worry about that. But with the tumor size, you can see that drastically tumor size can be reduced. And such studies really prove that it is a great hope with this advanced model. So I change the gear. Before that, this is the beauty of NIAB, and I had this bad habit of taking a lot of pictures wherever I used to. NIAB is very सस्ता, 1100 वाला और उसके बाद आने लग गया था 2022 वाले. But then इसको काफी लोग Director of Translational Health Science Technology Institute for 6 months, and there I could help and very closely watch that at COVID time, one of the models I have shown you is take a human gene for expressing ACE2 receptor, make a transgenic mice where lungs of the transgenic mice expresses human ACE2 receptor, throw the SARS-CoV virus has infected but it was found that cancer by itself had so many characteristics similar to human beings, and they were used to test various drugs for the SARS-CoV-2 virus. So, but what is the very nice thing that we infected is 10 to the power 4 or 10 to the power 5 is right. You see, this is a pattern of the loss, and it is very well known that this is a control, and these are the treated with various infection 10 to power 4 PFU or 6 PFU, and how lungs become very bad by day 7. That's what used to happen in case of COVID-19. Similarly, we used to enlarge in case of COVID-19, it enlarged in that. And then by 14 days, these lungs will return to normalcy, more or less, both the treated and controlled. And same is this mean that it will from a very big screen become to normalcy. If you remember very well, 14 दिन का क्वारंटाइन करना है, 14 days क्वारंटाइन, तब तक लंग्स नॉर्मल हो जाएगा. एक्चुअली 14 दिन में एनिमल का भी लंग्स 14 दिन में कम होता है, उसका जो स्प्लीन है वो भी 14 दिन में normal हो जाता है. That means the load of infection drastically declines. Naturally, it's a better model of the SARS-CoV-2 disease because it is mimicking human property. That actually going to the because we are HCC2 receptor in the artificially. So I think it's a better model, and a lot of drugs are developed using this model of hamster. So you can do several other things, biodistribution in animal models, pharmacokinetics in animal models, in vivo stability, metabolic studies, molecular imaging, where the cell is going, cancer cells, where they are moving, if you give drug, what happens to them, assessment of the therapeutic potential, that is tumor regression, etc. So there is a usefulness for clinical application, and molecular imaging, radiotherapy nicely. Now, the most modern thing has started coming, and that modern thing is that you were giving the hematopoietic stem cells to the bone marrow of the mice, and the blood cells from the mice were of the human origin. Then you added cancer cells making xenograft. So there was no rejection, chances of rejection were less. Immune system were more or less like liver. Now what they have done, they know that liver has a rate of a lot of metabolism of various drugs and therapeutics, and they also knew that there is a huge role of fetal thymus for the development of the immune cells. So what they have started doing now is the fetal thymus, fetal liver, and transplant that also into the mouse. So you have got a model which has got now. So they implant under the kidney capsule is placed the fetal thymus and fetal liver cells. So body has now thymus, liver, and bone marrow cells of human origin. So it's a far better model than what you used to do, and they call it the BLT model. And basically, you have made a humanized mouse where so many organs of the body are participating for response. So this is a very wonderful advanced model, and I will not go into detail. I will stop here because this same way which has been developed, and I do not care. So this is the time of COVID-19. When I used to come to office, and I don't think I have this case. Yeah, come and go around, and everybody was sick, and God was with us, and we got the time. So this is you can see. Yeah, it looks like this now, and I don't know medical biology, right? So I take an example of how you can convert a problem into a solvable problem. I give you including medical biotechnology. I'm not trained animal biotechnology. I'm not trained medical biotechnology animals again. I'm not a human. So I past years, sperm count is declining globally. And if this is the way the sperm count is declining, it's very, very threatening. One day we will reach around 240, 50. But this is a trend graph, and trend analysis goes in this way. There is no rise and down, right? Not like this. It is coming one way. It's going down, down, and down. So this was a matter of why that people will recover hypothermia very soon. Now, but these are all various countries, and see how the sperm count is going down. Actually, so it's one way right. Something is going. Why it is going down? It's very difficult to find out. So when a doctor sees a patient, he gives FSH and testosterone. How do not. So they don't know what is the reason. For that, we have to understand testis, when is testis, and if you take ultrasound, you will find in the brown area in that of a Sertoli cell. The dotted things are the germ cells. So Sertoli cell nurtures the germ cells and grows them. So Sertoli cell is the mother cell. Germ cell की वो माँ है. वो क्या करती है? It holds germ cell in various stages of development. छोटा बिल्कुल छोटा दूध पीता, फिर खाता, फिर सरल खाता, फिर भूख से मिल जाएगा, बड़ा होगा, and then it will fly away. This is a single Sertoli cell. Receptors for testosterone on Sertoli. So we assume that hormone देने के बाद भी if a doctor gives hormone and the patient doesn't give his sperm, that means possibly Sertoli cell is deficient in something. We did publish I'm not talking that those are our biggest publications and from that produce also. So let me see what it does. So let us assume that Sertoli cell is a rickshaw. But you know, rickshaw is just pulling a car, which is a germ cell. But that germ cell is not important. The role of Sertoli cell is to take the germ cell to a destination. But what is important? The genetic information carried by the germ cell. So what a rickshaw is doing is Sertoli cell. It does everything. It has got all lot of things, and its role is to carry it and go up to the gate of the semicircular lumen and help in its permeation of the motile sperm, which is this. Very fast this will run and will fertilize the egg. But if the Sertoli cell is defective, there is no way this car can drive by itself outside this net. So we started studying this Sertoli cell that find out what are the defects in these Sertoli cells. So you have to understand biology before you do the science. So I was just giving you fertility where hormones. So in infancy, a baby, 6-month-old male, has FSH and testosterone as good as his father. Then everything is shut off. Long duration, then puberty comes, again these hormones go up. At this time, Sertoli cell is naive, a childlike, it holds the germ cell but cannot help germ cells to grow through the ladder and every spot. At this time, puberty, probably Sertoli cell has grown and has become big. And it is able to now respond to this rising hormone at the time of puberty and help the germ cells to become strong. So, what is problem for us that the man will become to hospital at this time? He is fertile. Either he has high hormone or I give him FSH and testosterone and he is not producing sperm. So this situation is same and that in infancy. High hormones, no spermatogenesis. So I said monkey is a good model of human reproduction specifically. So if we can take out a and this will lead to what is the defect in fertile patient probably same. Because in adulthood, what happens is actually this testis and in fact, and response to hormone and next form. But it's certainly because this or this switch is lacking, they keep on going straight line. If I can compare the protein genome of this circle cell with the adult circle cell, probably I find out the proteins, and then is whatever which are important for helping surveillance. We did this study and very fast from here. We know adult testosterone is giving goodies by circular cells, helping germ cells to become sperm. And in infancy or in an infertile patient, hormones are unable to make the goodies and there is no spermatogenesis. So we started working with monkeys because human beings are like monkeys. We started how to ask a monkey. I want a pivotal circular cell, right? The pivotal happen like that. On that day, either train is going to go straight or the train is going to take a right turn and become pivotal, right? Straight gap तो pattern रहेगा. अब monkey is not like human कि मैं उसके कान में पूछूं, how are you feeling? Pivotal, do you feel? So monkey cannot say me. So what I have to do, I have to create a monkey which I know that on 24th of August he is going to become pivotal. So we take juvenile monkeys which do not have what's given GnRH, and we used to do a lot of surgeries in them. So how good model we make. And we did surgeries, implanted catheters. Every 3 hours we used to include GnRH process like adults, and within 1 month, 28 days to 30 days, that monkey used to become like adult. Testes. I knew bloody hell, this is the puberty. I cut the testes, I take the submission culture as an active circumcision and compare it with infant, which is 6 months से younger होना चाहिए. We used to accept the model of monkey, and we did that. And you can see in the same monkey, this is the situation. After 6 months, spermatogenesis started, and we see advanced spermatogenesis from the sides, and see the size of some different so much. So we cut open and started doing differential genomics, differential proteomics. I'll not tell you all those things. So that's so many students have gone through 15, 20, I guess, doing that. So you can do DNA microarray. This is differential display. We have done 2D electrophoresis and done differential proteomics also. So let us say what happens. Just make a 2 lengths of impact. One gene is increased, and which is less in puberty. So probably in infancy, this gene was increased and suppression is found. In other scenario, in infancy, 2 genes are less. In puberty, those genes are up. If I reverse the phenomenon, what happens in infancy, if I induce in puberty, and what happens in puberty is suppressed, I must see a infertile adult. Do you agree with me? If I reverse the phenomenon. So let us see whether transgenically we can do that or not. DR or DNA macular edema. I don't want you to go there. But out of several genes, we picked up a gene called as BCOP-K3 because BCOP-K3 is involved in embryonic development where there is a lot of cell division, signaling, and there is no expression in the cancer cells. So testis is also a place like cancer. Every day a man produces 100 million. So mitosis is huge. But you don't see cancer of testis is very common. But it's a situation like that. So we picked up this gene. So many genes picked up this gene to study further. Now there's a problem that how to study gene function in whole animal. One way is to do making a transgenic animal, but it is very, very difficult because I said my genes have to be taken and inserted into the mice, and then it will make a transgenic animal. So before that, what is the gene? So you must have a promoter and a termination codon. And what we have to do is machine will churn out several genes. And we'll talk about gene number 2344, 2345. Then you ask machine, what is the role? I'm a blind guy. I only go through the DNA. I give you starting codons. I give you termination codons. Period. I say this is a gene and give it a number. You human beings, what is the function? How do we do that? For that, we have to remember that we have a promoter, and this is the gene of interest which is to be expressed, and this is a termination codon. You need a promoter. Promoter's role is drive a gene and a tissue specific manner. But brain expresses some, testis expresses other, expresses other. Who does it? This promoter does it, which is very much tissue specific. And what we can do is now what we do is actually So we insert hey, you stay here. And then you find that this gene has gone in, and now it will go and catch another egg from here, bring it here. So superovulate female have lot of eggs. One by one, you bring the egg, and from an injecting needle, you inject the pieces of DNA, and that DNA is getting injected here. This is a sperm trying to enter in a fertilized egg. Can you see? So male pronucleus receives the gene of interest. So what happens after doing so? After doing so, we have inserted the foreign DNA into the egg. We make a surrogate female. That means it is mated with a vasectomized male. The female has a feeling I am pregnant, but she is not. In her womb, we kind of transfer these eggs which are surviving. So out of hundreds of eggs, maybe 10, 12 survive and become blastocysts. We transplant them and pray to God that they should implant, and at the time of cell division within the embryo, they should get integrated and make a transgenic animal. The first transgenic in India was made at National Institute of Immunology, which is HBV-X gene, hepatitis B virus X gene, which causes cancer of liver, and it actually caused cancer of the liver. Just a single piece of DNA. And then what will you have for a liver cancer? Study whatever you want to study, how it occurs, how to treat it. Can you make a biomarker ahead of time? Because you guaranteedly know that at the age of 45 days, these mice will develop cancer. In human beings, you do not know that. Human being comes to the clinic when he has developed cancer. How do you find a biomarker? You cannot. But in such case of animals, transgenic animals, that is the beauty. Isko bhi karo. So this is buffalo egg. And in buffalo, we did cloning job. That means this is a polar body stained with hex dye. This is actually inside the egg. This is outside. So we remove the inside the egg nuclear material and throw it out. And then we have cultured cells which are transgenic cells. So we take their nucleus and insert into this enucleated egg. So the egg's support will go to this added nucleus, and the added nucleus will now grow under the influence of the blank egg. Next, so for example, if this was the green fluorescence protein expressing cell, we take out their nucleus and inject it into that egg, which is enucleated. Now, if an egg of buffalo is formed, embryo is formed, it should be green because I have inserted green fluorescence protein. Ideally, buffalo embryo is not green. You see, when you just turn off and turn on the UV light, you see one of the eggs is showing you inner cell mass and trophoblast, which is green. Other egg is not showing you that much, and out of 3, 1 is showing you the GFP. Very convincingly convincing that cloning can be one of the method of the transgenesis. A gene can be transferred that way. Thank you. You need costly equipments for that, and it's very, very difficult because you have to kill hundreds of animals, even mice, to get hundreds and thousands of eggs for making transgenic animal. You need to develop in NIAB. I think it took 2.5 years minimum when we started working actively. It's a very time-consuming phenomenon. If Nilanjana can do it now, I say I challenge that any one of you try to work with her. He will take at least 1.5 years to learn from her. That is time required. So there's a lot of coordination between brain, hand, and I don't know what else, focus, whatever. So we started thinking, can we find out some alternative to this? Is a very costly affair, very difficult. In a year, I used to produce only 5 or 6 mice for the whole country at NII, which was very, very painful. We knew that these all things happen when the embryo is dividing and there's a lot of crossing over. You throw a foreign gene, and in hotchpotch, it gets integrated somewhere. So, for example, I will explain you there is a planned dance program. Let us say because very famous Hema Malini, and there is a program going on where she is dancing by herself. It's a big program. Police force is there, CID is there, and all government dignitaries are there. All of a sudden, the gene, want to dance with her. And I just say, मैं बहुत गजब का है, मेरे को भी नाचना है, मेरे को नाचने दो, मैं जाऊंगा यहाँ तो पुलिस आएगी, गोली लगाएगी, पकड़ेगी, अंदर करके मुझे लेके चली जाएगी. Because the organized program going on. Let's say, साबुन से ग्रो हो रहा है क्या? कुछ नहीं हो रहा है. इसमें तो बोलेगा यहाँ तेरी एंट्री नहीं है, कुछ नहीं हो सकता यहाँ. तो ऑर्गेनाइज प्रोग्राम. Now I go to a bar. I have never gone, but कुछ ऐसा फोटो हो अंदर में, डिस्को कहते हैं इसको, डिस्को बार. वो कोई नाच रहा है, कौन ड्रिंक कर रहा है, कौन क्या कर रहा है, किधर. हाँ भी मेरे को उनको देखे नाचने की इच्छा हुई. आई एम द जीन. ऐसा ही want to indicate बोले चल आ जाए अपने देखता कौन है नाच जीतना बाकी तुम नाचना है. So I am out to enter and catch with them. I was surprised. Why? Yeah, everything is in here. कुछ नहीं रहा है. ना नाचना और नाचना. So you know, every at the time of embryogenesis, and the gene got some place to get entangled and dance with the chromosome. Stayed there for it. Now, this is another place where this form is being made. And I always